Hello students, welcome to an academy. The today's session is related to Hydrology AE. This is session number 13. We are going ahead with the topic of hydrograph for Hydrology AE and AE. So I am going to give you one clarity related to it. The depth of subject what I am teaching is restricted to only EE. Don't try to crack GATE and ESE by listening this video, because I want to make the students to be very clear. I don't make them to confuse more. I don't say by attending this you are going to crack GATE and ESE. The depth of subject related to hydrology I am giving here is only for the depth for only for AE and AEE, not for GATE and ESE. Is it clear? Do you understand? So if you want to crack GATE and ESE, don't depend upon any YouTube channel. Don't depend upon any kind of free classes. By listening to free classes, you never crack GATE and ESE. To be frank, I am a teacher who suggests the perfect solution for students. I don't want to give wrong direction to the students. Clearly I am saying, don't confuse anything related to the subject. Whatever you are learning in the free classes is just basics, and those basics are not enough, not sufficient to crack GATE and ESE. Depth of subject required for GATE and ESE is too much. You are just learning basics in the free classes. So don't hope so and don't dream so. By watching any kind of free videos, you are going to crack GATE and ESE. Okay? But regarding AE, 100% sure what is exactly needed to crack AE. That is what I am teaching here. Okay, that is what exactly the depth required for AE. That is what I am teaching. Done. The today's session is related to hydrograph. Good evening, Rahul Gautam. Today's session is related to hydrograph. So first we write down definition for hydrograph. So everyone knows regarding hydrograph. What you will say immediately? Immediately you are going to say hydrograph is discharge versus time curve. Everyone know about it now? Anyone don't know about it? Everyone knows about it. Hydrograph is discharge versus time. So we have different curves. We have different curves, right? Do you remember we have studied a lot? Hydrograph. We have studied hydrograph. We have studied DAD curve. We have studied mass curve, rainfall mass curve. And also we have studied rainfall double mass curve. I am giving a single page consolidated list of curves so that easy for your exam preparation. Rainfall double mass curve. And finally this hydrograph. Finally this hydrograph. So we can say hydrograph is intensity versus time curve. Intensity versus time curve. DAD curve is depth, area, duration curve. And which is a very important related to DAD curve, falling curve. which is a falling curve. Rainfall mass curve. Cumulative rainfall depth. Cumulative rainfall depth versus time. Accumulated flow versus time. It is a rising curve. Remember, it is a rising accumulated flow versus time. It is a rising curve. rainfall double mass curve, very important, most repeated, required to check consistency of rainfall record, required to check consistency of rainfall record attestation, required to check consistency of rainfall record attestation. Now finally, discharge versus time. What it is representing? Discharge versus time hydrograph. What it is representing? It is representing stream flow fluctuations. Stream flow fluctuations due to effective rainfall. Hydrograph representing stream flow fluctuations due to effective rainfall. This is related to hydrograph. So match the following question will come, or theoretical questions individually also they will ask. Most important related to, clear, most important related to hydrology, theoretical questions. So these are the 5. Hydrograph, DAD curve, rainfall mass curve, rainfall double mass curve, and hydrograph. Okay, we'll move on. Now I am writing definition for hydrograph. The plot drawn between discharge of a stream, as a result of runoff contribution into a catchment, as a result of runoff contribution into a catchment, against time duration, is considered as hydrograph. So what the hydrograph is representing? It is representing runoff contribution into the stream. And it is a picturization of stream flow variation. Representation of, very important, flow into the stream during rainfall. That is varying. Flow into the stream during rainfall. Clear? Representation of stream flow variation, flow into the stream during the rainfall, modified. That modified flow into the stream, that is taken representation of stream flow variation, that is said to be, that is considered as a hydrograph. Okay, we'll move on. So for example, this is a catchment. Rainfall occurred into the catchment. and this is outlet of the catchment stream. This is catchment, okay. This is said to be catchment, and this is outlet of the catchment considered as a stream. Outlet of the catchment considered as a stream. Okay. Now rainfall contributed some amount of rainfall. Rainfall contributed some amount of rainfall into catchment. Now the catchment allowed the flow after some storage, after accumulation. The flow is traveling from catchment to stream. Will that flow is constant throughout the duration? Tell me. Will that flow entered into the catchment after getting accumulated rises and slowly transferred to stream? Will that stream flow, is it constant? That flow received at the stream is said to be stream flow, varying with respect to time. Stream flow is varying with respect to time. Now the observer, the hydrologist, measuring the stream flow at a certain location. The hydrologist measuring the stream flow, for example at this location, he is measuring the stream flow at this location. Discharge is getting measured and he is knowing, you understand, is calculating first hour, second hour, third hour, fourth hour till. So in the beginning, in 0th hour, stream flow is having some value. Let us take 0 hour stream flow is considered. Let us assume x meter cube per second. Then first hour, second hour, third hour, like that it will continue. X plus 1, x plus 2, x plus 3 value goes on increasing. And finally again at t hour, it reaches near to x. So it started raising from x, go on increasing after the x to increase. Then after a certain time it go on decreasing and finally reaches to x. So x more than x, more than x, more than x, more than x raises up, fall down, fall down, fall down and again reaches to x. So this 0 to t hours, 0 to t hours, flow is so showing some fluctuation. Started with x meter cube per second and ended with x meter cube per second. In between x to x at 0 to x at t. You understand? In between x meter cube per second at 0th hour and again x meter cube per second at t hour. There is variations which are greater than x. These values which are greater than x, these are called flow variation. We are studying in hydrograph these flow variation. Who is responsible for the variation? Why stream is not showing same constant discharge? Who is responsible? Why flow is varying? Who is responsible? Flow is varying because additional discharge entered. Clear? Additional discharge entered. Who is providing additional discharge? Additional discharge from atmosphere rainfall. Rainfall is contributing additional discharge. Flow is entering. Due to that flow, you understand? Additional discharge is contributed. Yes. Correct, Rahul Gautam. Addition of rainfall causes variation. X, x plus 1, x plus 2, x plus 3, x plus, whatever the value, some values. Variation. That variations are caused due to rainfall. Now we are studying those flow variation. We are not taking total discharge in the stream. Remember the point. The stream may carry certain constant discharge, this x. Higher than x, whatever present, that is only we are considering. More than x, whatever it is present, that is only we are considering. Remaining we are not considering. This is additional additional flow. That additional flow versus the time we have plotted, that is called hydrograph. Do you understand what is hydrograph? When a rainfall occurred, immediately direct runoff entered into catchment. From catchment it traveled towards the stream. That excess flow from the catchment entered into the stream raises discharge in the stream. That excess raise in the discharge versus the time is plotted. That is taken as hydrograph. Clear for everyone? We'll move on. So now we are plotting discharge on a y-axis, discharge meter cube per second on y-axis, time in hours on x-axis. Discharge meter cube per second on x-axis, time in hours on y-axis. Sorry, discharge in meter cube per second on y-axis, time in hours on x-axis. This is the hydrograph curve. This is hydrograph curve. It starts with O and the rising point is A and it reaches to peak value B and this is inflection D and this is end of direct runoff E. So why it is not started with 0? And why it is not ended with 0? Why the flood hydrograph? This hydrograph what we are talking here, remember carefully. This is a hydrograph what we are naming flood hydrograph, storm hydrograph, clear, FH, flood hydrograph or storm hydrograph. FH, flood hydrograph, SH, storm hydrograph or total runoff hydrograph. Same, total runoff hydrograph. What is a total runoff, Rahul Gautam? What the total runoff hydrograph include? Total runoff hydrograph. That total runoff hydrograph is a sum of base flow and direct runoff. Sum of base flow and direct runoff. When there is a base flow? Tell me when there is a base flow? Base flow happened at any time irrespective of rainfall. Throughout 365 days, subsurface flow, groundwater table flow will enter into catchment. So every day, even there is no response from rainfall, this amount we are considering as base flow. That amount, what is, why we have not taken 0? That amount we are considering it as a base flow. So for our easy convenience, remember the point of raise is A and the point of end of direct runoff is E. This total below line AE, base flow, total above line AE, DRO. I think you remember what is base flow and what is direct runoff. Yesterday discussed, around 30 minutes we discussed about it. What is base flow and what is direct runoff? The contribution from subsurface flow and groundwater table irrespective of rainfall, that is base flow. Irrespective of rainfall, that is base flow. So this time duration where point of raise starts, where runoff ended up, this is called time base, TB. This is taken as TB, time base. Point of raise to point of end, TB, time base. I will explain you. Here to here, rainfall started at 0th hour. Will immediately after rainfall stream will receive discharge? There is a time lag. Na? You got the point. Rainfall started at 0th hour here. Stream is located, you are measuring here. To travel this distance a certain time, what we call time of concentration. There is a lag in a time from the starting of rainfall to entering the discharge into stream. That lag, this gap, starting of rainfall to initiation of additional discharge in the stream, that lag, so that it was not plotted. Unit hydrograph, Mr. K, for 1 centimeter depth. If you have considered rainfall for 1 centimeter depth, not rainfall, effective rainfall, runoff. Unit hydrograph. Mr. K, unit hydrograph. Hydrograph for 1 centimeter effective rainfall, direct runoff. 1 centimeter effective rainfall depth. For unit depth, 1 centimeter is called unit depth. 1 centimeter is called unit depth. That is taken as unit hydrograph. Okay, Mr. K. Now we are talking about, here we are discussing about hydrograph. So we have not started at 0th hour. Everyone got the reason? Rainfall started at 0th hour. But a contribution by the rainfall at a stream. Rainfall started here at 0th hour. Contribution by the stream. So to travel from this point to this point, it needs a certain time. That the time lag we have considered. Then 0 to A, O to A. The amount of water is not considerable rise. That not considerable rise to approach the stream and raise the discharge. So because of that reason, very small variation, not considerable variation, 0 to A, O to A, approach segment. Flow is changing. Changing means 1 meter cube per second is initial. 1.01, 1.04 it is showing. Not 1 to 2, 1 to 3. Just a small little variation but not considerable. That is approach segment. But suddenly when it reaches to A, flow immediately rises up. That is A is called point of raise. Point A is called point of raise. Hereafter continuous raise of flow. Flow rises, continually rises up to B. What is AB? AB in the curve is called raising limb. AB in the curve is called raising limb. Remember carefully. Here, A to B, point A to point B in the curve, that is considered as a raising limb. Then C. What is C? Point of peak discharge. Point of peak discharge. Highest discharge is available. Peak of flood hydrograph. Where it is located? This is only na. This point only na representing. Peak discharge is showing at this point. Maximum discharge is showing at this point. So this is called point C. Point C. Peak discharge. Crest. This total we call it as crest, Rahul. B to D, whatever present, this total area. This total area B to D. This full, we consider it as a crest. But C is a peak discharge. So, the time to reach peak discharge. Point of raise is started at A. Peak is achieved at C. This time taken from point A to C time to reach peak discharge, TPK. Time to reach peak discharge. Point A is started at this location and peak is achieved at this location. From that point A to C, point time to peak discharge. So QPK. Now C to D. Not C to D, B to D. We'll consider B to D. So B to D, what we take it as a crest segment. B to D will consider it as crest segment, top crest segment. And D is said to be point of inflection. D is considered as a point of inflection. What is inflection going on here? Falling down after D. What is inflection going on after D? What happened to discharge? Discharge is the same after D. Discharge is falling down after D. Falling down D to E. Discharge is falling down D to E. Decreasing now. So D to E we call it as recession limb. D is falling, point of fall. D to E is taken recession limb. Inflection point, falling point, falling point. D is the falling point or inflection point. Yes, decreases with the time. D to E, recession limb. What is E? End of surface runoff. Point representing end of direct runoff, DRO. Point representing DRO. So after DRO ended up, what is there in the curve? After direct runoff ended up, what is there in the curve? Remaining is base flow only. No? Remaining this point is taken as base flow only. No? End of direct runoff, this is ending point. End of DRO. If no DRO, what is there in the stream? If there is no DRO, what is there in the stream? Base flow. Here, direct runoff is ended up. What is there in the stream? Base flow only there. So, this flood hydrograph or total runoff hydrograph, these are the points we are having. 0 to A approach segment, A point of rise, A to B raising limb, C point of peak discharge, B to D crest segment, D point of inflection, D to E recession limb, E end of direct runoff. But what it is representing? Just it is representing flow variation. Just flood hydrograph is representing. Flood hydrograph is representing flow variation. What is the time of effective rainfall? Effective flow. Time base na TB. TB. Time base. Point of rise to end of DRO. Effectively direct runoff entered into stream. The time for which effectively direct runoff entered into stream. Here, TB time base or base period for which effectively direct runoff entered into the stream, which is taken between point A to point E. We have a formula to know about this time base. Time of effective DRO, time of effective DRO into stream. This is determined using the formula. N is equal to 0.83 into A power 0. A power 0. N is obtained in days. A is taken in kilometer square. Here A is considered in kilometer square, N is obtained in days. You have to convert to hours. How many hours effective rainfall entered into the stream? So there is a previous question in A exam. The number of days of effective runoff happened N, given by the formula 0.83 into A power N. N stands for, in the formula N stands for, that is the question. What is N represents? Tell me. Small n represents, what is the formula? Question is regarding formula they provided. Formula they provided, question is regarding exponent value. This value, n is equal to, yes, area of catchment, correct. A is area of catchment, Rahul Gautam, no doubt. A is area of catchment only. N represents, n is equal to 0.2. No? Regarding this 0.2, they have asked the question. Yes, this is in days only. You can convert, later on you can convert to hours. You are obtaining according to the formula, you are obtaining n in days, time. This is the time, Rahul Gautam. This is the time. This is area of catchment in kilometer square. Area of catchment in kilometer square. N is equal to 0.83 into A power 0.2. Small n is 0.2. Question is about a small n. This is previous question in AEAW. Very important. Now, direct runoff hydrograph. Direct runoff hydrograph, DRH. Direct runoff hydrograph, DRH. What is a direct runoff? How you will get it? How you will get direct runoff? So discharge through direct runoff is equal to discharge through flood hydrograph. You know ordinates of flood hydrograph, na? Subtract base flow minus base flow. Discharge through direct runoff is equal to discharge through flood hydrograph minus base flow. QDRO is equal to QFH minus base flow. This is a direct runoff hydrograph ordinates. Yes, correct. Subtract base flow. So when you have subtracted this region, tell me what you are getting. When you are subtracting base flow, this is only base flow region. Na? This is only base flow region. Na? You have subtracted base flow region. The bottom region is taken as base flow. So DRO. It starts with 0, ends with 0. Na? When I am going to plot for direct runoff, I am going to plot the graph for direct runoff. It is not going to start at 0th hour, but it is providing discharge of 0, started with the discharge of 0, ended with the discharge of 0. If I have taken only for time base, I am plotting only for time base. This is the direct runoff discharge I am taking. Direct runoff discharge I am taking. I am plotting only for time base. This is curve of direct runoff. Starts with 0, ends with 0. This is a peak discharge of DRH. Peak discharge of DRH. Direct runoff hydrograph. So what is the total time here? Total time what I have considered. Total time what I have considered. This is taken as a time base TB. This is taken as a time base TB. Is it clear? Starting of direct runoff to ending of direct runoff. Total time duration. Time base TB. Time base TB given. So this is peak discharge QPK, peak of DRH. Peak of DRH. What is excluded? Base flow. What is excluded? Excluded is base flow na. Excluded base flow. Only thing you are subtracting. You are subtracting base flow. That is only the thing. So I am going to take now very important, which is required for your exam. Estimation of volume. Whose volume? Estimation of volume of runoff into catchment. How much volume of water entered through the runoff into the catchment? Here, during a specific rainfall. During a specific rainfall. How you will get volume of runoff? For a specific rainfall, how much effectively entered into catchment? The volume of water, quantity of water. Today some rainfall occurred into some catchment area. How much volume of water effectively entered into catchment area? That volume of runoff is equal to, we'll take first model of formula, area of catchment into effective rainfall depth. Depth into area is volume, na? Area of catchment into effective rainfall depth. That is volume. First formula. Volume of runoff water entered into catchment. Not rainfall, Rahul Gautam. Effective rainfall. Because total rainfall is not entered, na? Total rainfall is not entered, na? Only effective rainfall, direct runoff is entered. So area of catchment into effective rainfall depth. What is effective rainfall depth? So we can consider effective rainfall depth. How we can calculate runoff? In infiltration we have solved so many problems. Effective rainfall depth R is equal to precipitation minus phi into T. Do you remember this formula? We have solved so many questions in infiltration. R, effective rainfall R is equal to phi, precipitation P minus phi, infiltration index into T. That is effective rainfall depth. That is providing you effective rainfall depth. Same, I am writing formula 2. I am going to write formula 2 for the same. For what? For what? Volume of runoff. Volume of runoff entered into catchment. Area of direct runoff hydrograph. Area of direct runoff hydrograph. So this total area we will take na discharge into time. Is it not? We will consider it na total area of direct runoff hydrograph. This is taken as discharge into time is equal to volume. You understand? Whatever total area discharge into time, that is equal to volume. So area of DRH. To calculate area of DRH, we have different formulas here. To estimate area of DRH, depending upon the shape. Depending upon the shape. For a triangular DRH, triangular direct runoff hydrograph, how can we take area formula? How can we take area formula? Half into base. What is the base? TB, time base, na? A triangular direct runoff hydrograph. This is the direct runoff hydrograph triangular you have plotted. And the base is the time base. And the top one is peak discharge, QPK. So what is now you are getting triangular DRH? Half into time base into peak discharge QPK. That is area of DRH for what? Triangular direct runoff hydrograph. Clear? Half into base into height, half into time base into peak discharge. So you ensure time base must be taken in seconds because your discharge is given always in meter cube per second. Don't take time base in hours because your discharge in meter cube per second. Second condition, we are moving ahead towards the second condition. Trapezoidal DRH. Trapezoidal DRH. The trapezoidal direct runoff hydrograph I am plotting here. So this is the trapezoidal DRH we are having. Again height, peak discharge of DRH. Time base is taken as A. A, what I am taking time base. And in trapezoidal DRH, what is advantage? Peak is continuing for long time. Na? This peak is continuing. Time for continuation of peak discharge. B. Now, what is area? Now for area of trapezoidal DRH, what you can write down? Area of trapezoidal DRH, what you can write down? A plus B by 2 into peak discharge. Very good. A plus B by 2 into peak discharge of DRH. A plus B by 2 into peak discharge of DRH. Irregular shape. Non-uniform shape. Irregular shape or non-uniform shape. What we can consider? Trapezoidal integration formula. So actually we are having DRO in this shape now. Actually we are having DRO in this shape now. Are you getting triangular trapezoidal? You are not at all getting triangular trapezoidal. You are getting triangular trapezoidal for your exam point of view. For AE, AEE, GATE, ESC point of view, we are taking triangular trapezoidal. Practically, this is the shape. This is practical shape. So, trapezoidal numerical integration formula we are taking. Area or volume of DRH or volume of runoff. Area of DRH or volume of runoff. Q0 plus Qn by 2. This is Q0 and this is Qn. Q0 plus Qn by 2 plus Q1 plus Q2 plus Q3 and so on. Qn minus 1 into change in time, difference in time, delta t. Change in time, difference in time, delta t. What is Q0 and Qn? Q0 is 0, Qn is 0. So this total what we can take? 0 only. 0 only now. Q0 is 0, Qn is 0, the total Q0 plus Qn by 2, 0. So now, area of DRH is equal to simple. Sum of discharge values Q1 plus Q2 plus Q3 and so on. Qn minus 1 into delta t. Sum of discharge values, summation of Qi into delta t. This is area of DRH. Clear? Is it clear? I will give you one shortcut. Volume of runoff expressed by two formula. One is area of catchment into depth, area of catchment into depth. Whose depth? ERF depth, effective rainfall depth. Second one, area of DRH. Area of DRH. We have three formulas here. First one, area of catchment into ERF depth is equal to, for triangular shape, what we can take? Half into time base into peak discharge. Second one, same, area of catchment into ERF depth is equal to A plus B by 2 into peak discharge. Third one, same, area of catchment into ERF depth. Depending upon shape, you select the formula. Summation of Qi into delta T. So total 4 parameters. Area of catchment, effective rainfall depth, peak discharge, time base. Out of the 4, 3 given, 1 unknown. Remember, out of the 4 parameters, what are 4 parameters? Area of catchment, ERF depth, peak discharge QPK, and time base. 4 are there now. Out of this 4, 3 given, 1 determined. Very important. This slide, compulsory, you have 1 question mandatory from this slide. Very important for any examination. You make 100 stars for it, because it is very important. It is very important. 100 stars you make. Out of 4, 3 given, 1 you need to determine. 1 numerical question. For today, I am going to close the session, because again at 6 o'clock, I have a class at Unacademy app, 6 p.m. Ask any questions related to GATE. Whatever your queries, preparation, whatever your doubts related to, even regarding GATE application, even how to prepare, how to revise, how time manage, whatever your question, 2 faculty, myself and RP sir, both are available at 6 p.m. in a single class, myself and RP sir on a same window, we both are available. So we both give you solution for all your problems. Okay, we'll meet again at 6 p.m. So I'm going to close the session now. Thank you, one and all. Bye-bye.